Okay, so this video is about electron structure, and we're going to talk about the A-level electron structure up to krypton. Okay, so first just quickly do some GCSE revision before we move on to A-level. So in GCSE level, if you were asked to give the electron structure or the electron configuration of sodium, then you would look at the periodic table. You would see that it has an atomic number of 11, which means that there are 11 protons and also 11 electrons. At GCSE level, you would say that there are 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. Then they probably would have asked you to draw, this is like a model, and you'd have your nucleus, and you'd have your 2 electrons in the first shell, and then the 8 electrons in the second shell, and the 1 electron in the outer shell. Yeah, so that's GCSE, but we need a more complex model. More detail is needed for A-level. So as an A-level student, we're going to look at it in more detail. Okay, so the shells are actually made up. So this shell, which is the first shell, and then the second shell and the third shell, shells are made up of things called atomic orbitals. Okay, atomic orbitals. Atomic orbitals, yeah? So it's like you've got a really good magnifying glass and you're looking really closely at this first shell. Exactly where are those 2 electrons in the first shell? Which room? Whereabouts are they? We need a definition for atomic orbitals. Okay, the definition of an atomic orbital is a region or a volume, right? You can't say area because it's 3D, right? It's not flat, so you can't say area. A region or volume where there is the highest probability, of finding an electron. The highest probability of finding an electron. Probability of finding an electron. Okay, an orbital can hold up to 2 electrons. So it's like if you know electrons are moving around the whole time, yeah? So if you were to put like a tag, a label on an electron and follow the electron around, where's the highest probability of finding that electron? What region is that electron in? Okay, you need to know for A-level, you need to know the shapes of orbitals, these regions. So we're going to draw axes, yeah? So we're going to draw the x-axis, the y-axis. I mean, you don't have to draw axes. I just think it's good practice to draw the axes. And we've got a z-axis. So z-axis is sticking out of the paper above and below because it's not 2D, it's 3D, yeah? Now, an s orbital is a sphere, right? The middle, I forgot to point out, the middle is the nucleus, yeah? So an s orbital, lowercase s, okay, that's lowercase, not capital, lowercase, not uppercase, s orbital, and its shape is a sphere, not a circle, it's a sphere. Okay, it's 3D. That's called an s orbital. Then you have something called a p orbital. Okay, remember an orbital is a region of highest probability of finding an electron. Okay, x, y, let's do a z again. Okay, a p orbital is like a figure 8 shape. Okay, this is called a lobe, and then you've got another lobe. You've got to try and make them the same size, yeah? That little bit there is called a lobe. And try, like your earlobes, try and make them the same size. And this is called a p orbital, lowercase again. And the shape of a p orbital in exams, we call it a dumbbell shape. Dumbbell shape, like the the weights, yeah, dumbbell. That's a px. But as you can imagine, that's the x-axis. There's also a py. Yeah, so if you have a dumbbell shape across the y-axis, that would be called a py orbital. and then finally just squeeze it in. You've got a, oh, it's not very good, very squeezed in, X, Y, Z. You've also got a Z p orbital along the z-axis. Okay, so there are there's one s orbital. Okay, so let me write that down. One s orbital that can hold 2 electrons. There are 3 p orbitals. So in total we've got 6 electrons there. Now there's also other orbitals. There's d orbitals. And there's 5 d orbitals, but you don't need to know the shape of those anymore. And there are 7 f orbitals. Okay, so just a region of the highest probability of finding an electron. Yep. Okay, so let's have a go at writing some electron structure, and you need to know all the way up to krypton, yeah, up to element number 36. So let's start with hydrogen then. Let's start with atomic number 1. Let's start with hydrogen. Okay, so if you have the nucleus, let's say the nucleus down the bottom here, yeah, and you have the first shell. Okay, so hydrogen, if you were writing this as GCSE electron structure, you would just say hydrogen has 1 electron, and you'd say the GCSE electron structure is 1. Okay, but we're going to go into a little bit more detail for A level. In the first shell, you've got an s orbital. Now, this is called the box model. So I know the s orbital is a sphere, but we call this the box model. And we write the electron as a single-headed arrow. So a double-headed arrow means 2 electrons, yeah? So we're going to write a single-headed arrow like that. Okay, so there's 1 electron. So we're not going to use GCSE style anymore. Okay, for hydrogen, there is 1 electron in the first shell. First shell, that's the shell number. It's an s orbital, and there's 1 electron. So the number at the front is the shell number. The s is the type of orbital. And that number there at the top is the number of electrons in the orbital. The number of electrons. Yeah, okay. Now we're saying shell number. That's totally fine to use shell number. It's also called energy level number. So you could use that term. Or you can use the term, which is the official term, is principal quantum number. Quantum number. Okay, students who study physics will have come across this as well. Principal quantum number. And principal quantum number has a symbol N. Okay, so these 3 terms, they all mean the same thing. Shell number, energy level number, principal quantum number. Principal quantum number N equals 1 means it's the first shell. Yeah, N equals 2 means it's the second shell. So please don't be confused by that. Yeah, the second shell. Okay, so I'm going to make this, I'm going to change this a little bit, change it, and I'm going to say N equals 1, which is just the first shell. There's an s orbital, sorry, and there's 1 electron. Okay, right, so let's do the next element, and the next element is helium. Yeah, so that's hydrogen, and let's do helium next. Helium has got 2 electrons. Okay, so 2 electrons. So what we do, you don't actually need to know this, but the electrons spin in opposite directions. So electrons spin clockwise and electrons spin anti-clockwise. And when we put the electrons together in an orbital, we draw them as spinning in opposite directions, and that overcomes some of the repulsion. So helium is first shell, s orbital, and there are 2 electrons. Okay, now the first shell is now full. There's 2 electrons in the first shell. So we're going to go to the second shell. Okay, and as we go away from the nucleus, we're going up to a higher energy level the further we go away from the nucleus. Okay, so N equals 2 is the second shell. So we're now on to helium, we're now on to lithium. Okay, lithium has got 3 electrons. So there's 2 arrows there, and each shell starts with an s orbital. So we need another electron there. So we've got first shell, there are an s orbital with 2 electrons, and the second shell has an s orbital with 1 electron. Remember what we would have done GCSE style? GCSE style, lithium would have been 2, 1. So 2 electrons in the first shell, 1 electron in the second shell. So we're just giving a bit more detail, saying exactly where these electrons are. Okay? Right, next one, lithium. And the next element is beryllium. Oh, sorry, change it back to black. The next one is beryllium. Yeah, beryllium. Beryllium has got 4 electrons. So we put another electron in. So it's 1s2, 2s2. Okay. Boron has got 5 electrons. So the s orbital is now full. But not to worry, because we've got 3 p orbitals. Right. Remember, we've got px, py, pz. And we're going further away from the nucleus, higher energy. So we can pop an electron in the p orbital. So it's 1s2, 2s2, 2p1. Okay. The next element is carbon. Carbon has got 6 electrons. Okay. And you do not pair up the electron. Electrons occupy orbitals by themselves, singly. They only pair up when they have to. It's a bit like sitting on a bus. When you go and sit on a bus, you don't sit next to somebody unless you have to sit next to somebody. You sit in a seat by yourself. It's the same with electrons. So they only pair up when they have to. So carbon is 1s2, 2s2, 2p2. Yeah, and the next one is nitrogen. And again, it doesn't pair up because there's no need to pair up. 1s2, 2s2, 2p3. And the next one is oxygen. Now oxygen has to pair up because there's no more room, so it's going to go there, 2p4. 1s2, 2s2, 2p4. Yeah. So we just go back to the periodic table. We're now on nitrogen. Yeah. So nitrogen is 2p3. So it's the first shell, first row, second row, 2p3. Then oxygen is 2p4, then fluorine is 2p5, and then neon is going to be 2p6. Yeah. Then we're going to go to the third shell for sodium. Okay, so the shell is now full, and for sodium we're going to go to the third shell. So just tidy up a little bit here. The third shell for sodium. Okay, so the third shell, n equals 3. Every shell starts with an s. So sodium is there. So can you work this out yourself? It's going to be 1s2, 2s2, 2p6, 3s1. Yeah, and the next element, magnesium, will be 1s2, 2s2, 2p6, 3s2. And then the s is full because an orbital can only hold 2 electrons. So now we need to go to the 3p. Okay, so we go 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Okay, so as you're going across the periodic table, so we've got 3p1 for aluminium, 3p2 for silicon, 3p3 for phosphorus, 3p4, 3p5, and argon is 3p6. Okay, so we're at argon. So argon is all of that, 1s2, 2s2, 2p6, 3s2, 3p6, and we've got a full shell. Yeah, so we've got 2 electrons in the first shell, 2 electrons in the first shell. We've got 8 electrons in the second shell, and so far we've got 8 in the third shell. Right, we're now on to potassium. So potassium has gone into the fourth shell. 1, 2, 3, 4. Potassium is in the fourth shell. Okay, so potassium is going to be N equals 4. We start with an S. Okay, so potassium is going to be all of argon. So I'm going to be naughty and summarize it. I'm going to put argon in square brackets. So it's all of argon and 4s1. Okay, and then calcium as another electron. So calcium is going to be all of argon, all those electrons, and then 4s2. And the next element is scandium. Right, something slightly different happens here with scandium, so we've got to be careful now. So the 4s is full, and where are we going to go next? Where's the electron going to go? So it's not 4p, it's not 4p, it's actually 3d, and there are 5 d orbitals, and this is the 3d, that's 3p, that's 3s, yeah? So scandium is actually 1s2, 2s2, so 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, and then 4s2. Okay, so something a little weird happens here when you're filling up. You go filling up 3s, 3p, 4s, but then you go back to the 3d. So they're very close in energy, the 4s and 3d, they overlap. Yeah, that's scandium. And then what we got next? We've got titanium, and so titanium is all of that, 3d2, 4s2. Yeah, and then the next element is vanadium. Vanadium is all of that, 3d3. Remember, they singly occupy 3d3, 4s2. And then the next element along is chromium. Now something a little odd happens with chromium. 3d4, 4s2. That's what chromium should be, but chromium is an exception. Okay, it is more stable to have a half-filled subshell. So an electron comes back, and chromium is actually 3d5, 4s1. Okay, so it's not 3d4, it's actually 3d5, 4s1. Okay, so let me just quickly mention that these are called subshells, part of a shell. Okay, that's the 3d subshell. That's the 3p subshell. That's the 3s subshell, part of a shell. Okay, chromium. Then the next element is, after chromium, manganese, and it sorts itself back out again, 4s2. So chromium is 3d5, 4s2, etc. It goes along. Iron is 3d6, 3d6, 4s2. Okay, there is one more exception. Yeah, the other exception is copper. So copper should be, let's tidy this up a tiny bit here. Copper should be 3d9, 4s2 is what it should be, 3d9, 4s2. Okay, but it's an exception. And what actually happens is an electron from S drops back again, and copper is 3d10, 4s1 is the exception. Yeah, and then zinc sorts itself out again, and it becomes 3d10, 4s2 for zinc. Okay, 3d10, 4s2. And then on the periodic table, once you've done zinc, okay, so zinc, let's just check out where zinc is here. Then the next element, gallium. Okay, so we've filled the 3D, we've filled the 4s. gallium is going to have to go into the 4p. Right, so after the 4s, we've now got the 4p subshell. So gallium has an electron in 4p. So gallium is everything, 1s2, 2s2, 2p6, etc. Everything up to argon. Yeah, then it is 3d10, and then it is 4s2, and then it is 4p1. Gallium. Yeah, and then the next one is 4p2, 4p3, 4p4, 4p5, and finally a krypton is going to be 4p6. Okay, so in the shells, another thing you need to know, in the shells, so it is looking a little bit messy, I'm sorry, but let's do a different colour here. In the first shell, there's a maximum of 2 electrons. In the second shell, there's a maximum of 8 electrons. In the third shell, there's a maximum of 18 electrons. How many electrons are there in the fourth shell? Okay, so there's a formula you can use to help you. Yeah, so the number of electrons in a shell, the formula you need is 2n squared. Alright, so if we take the first shell, for example, the first shell. So the first shell is 2 times the first shell, n equals 1. That means that there are 2 electrons in the first shell. Yeah, the second shell, 2 times 2 squared, which is 8 electrons maximum in the second shell. In the third shell, so it's 2 times 3 squared. 3 squared is 9, 9 times 2 is 18, 18 electrons. And in the fourth shell, the maximum electrons in the fourth shell, 2 times 4 squared. 4 squared is 16, 6 times 2 is 32. So there's actually a maximum of 32 electrons in the fourth shell. You are asked for the electron structure of an ion. So if you take iron, for example, an iron is 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 1, 2, 3, 4, 5, 6, 3d6, 4s2. Okay, so that's the electron structure of iron. If you're asked for the ion, the 2 plus ion, then you need to remove 2 electrons, and you remove the 4s. Even though the 4s was filled first, it's the 4s that's removed when you remove electron. Okay, thank you.